Okay, welcome back to Senner's Math Classroom. Today we're looking at 2.6, rational functions. A rational function has a polynomial numerator and a polynomial denominator, axn over bxm. Our example, x plus 1 over 2x minus 3. First thing we want to look at today is the domain. The domain is all real numbers as long as the denominator does not equal 0. So if you solve for that, you get 3 over 2 in this case. So all reals except 3 over 2. You can write it in set notation x such that x does not equal 3 over 2 if you like. The VA, the vertical asymptote, is going to be that number you got from your domain. So x equals 3 over 2. The horizontal asymptote comes from comparing the exponents on the polynomials. So if n is less than m, then y equals 0. If it's equal, then you do a fraction a over b. If it's greater than none. In our case, they're equal. So we're going to do 1 over 2. A is 1, b is 2 in our example. This next example, we've got f of x equals x squared minus 4 over x squared minus x minus 2. If you have something like this, you might want to factor it because you might find something that crosses out. That's pretty important in this case. The domain is all reals except for the numbers that make the denominator equal to 0, which are negative 1 and 2. And the VA is usually those domain numbers, but in this case, there's a gap at 2 because the 2 was canceled out in the problem you factored in. The HA is 1, y equals 1 because n equals m. So 1 over 1 is 1. Alright, last example. F of x equals 3 over x minus 4. And the domain, all reals except whatever makes the domain equal 0. So that would be 4. You can't have 0 for the denominator. Okay, divide by 0. The VA is going to be 4. And so x equals 4. The HA is y equals 0 because the numerator's exponent is 0 and the denominator's is 1. Have a great day.